Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today we will be discussing more about fluid mechanics. If you recall the previous lecture where we have defined this fluid as a substance that deforms continuously under the application of shear stress. और इसमें इम्पोर्टेंट बात क्या थी? No matter how small the stress may be, even with little stress, you could deform a fluid, which is not the case when you are dealing with solids. So motivation of this course is I give you a remark at the end of last lecture that everything in this universe is either a fluid or lives within a fluid. So with this remark, you could see the motivation of studying this course. So what we drink is a fluid in water or any other drink. What we eat is a fluid, more specifically the non-Newtonian fluid. What we inhale, what we exhale, the medium in which we live, we walk through is a fluid. So everything in this universe is either a fluid or lives within the fluid. If you look the submarines in the water, so submarine is not a fluid, but that lives within a fluid that is an incompressible fluid, of course, water. Similarly, an plane that is moving through sky means it has to face the fluid, which is air, of course. So this is very important course. The blood flow in our arteries, in our body. Again, this is an example of fluid flow in pipes, flow in ducts. So this is very important course. So then we have some definitions like compressible and incompressible flow. The flows in which density variations are negligible or density remains constant, we say that is an incompressible fluid. Mostly all liquids are incompressible. Whereas if density varies, density is not constant, we say these are compressible fluid, gases, for example. So today we will be solving some numericals as well. If you are given some velocity field, then how would you determine that the flow field is compressible or incompressible? So let me solve a small problem. If we have a velocity field having the components u, v, w, so u component is x square plus y square plus z square, v component like xy plus yz plus z square, and w component negative 3xz negative z square by 4 plus 4. So now the question is whether the flow is compressible or incompressible. So this is some given velocity field of any fluid, and we need to decide whether this is compressible or incompressible. Of course, at the moment fluid is not in front of us, हम fluid को देख नहीं रहे हैं. So how we could prove mathematically that the flow field is incompressible? So we will compute the divergence of u. So you have read in your PDE's course, partial differential equations course, that this operator del or nabla is I partial v partial x plus j partial v partial y plus k partial v partial z dot. So this is the vector u. In this case, we have u, v, w. So what we get? Partial u by partial x plus partial u by partial y, sorry, partial v by partial y plus partial w by partial z. This is as divergence of u, which of course is a scalar quantity. Now, based on the output of this scalar, we can decide the following. If divergence of u equals to 0, we say the flow is incompressible. So there is no volume expansion. If divergence of u is negative, we say the volume is decreasing. If this is positive, then the volume of the fluid is increasing. So of course, the volume mean we are having some hypothetical control volume, और इसकी हम बात कर रहे हैं. If this is the control volume in consideration, so divergence of u equals to 0 mean the amount of inflow is balanced by the amount of outflow, and this happens only in the case of incompressible fluids. So let us compute the divergence in this case. So what is u? X square plus y square plus z square. I need partial u by partial x, that is 2x. V is given as xy plus yz plus z square. We need partial v by partial y, that would be x plus z. And the last component of velocity field is w minus 3xz minus z square by 2 plus 4. So partial w by partial z, that would be negative 3x minus z. So we are able to compute the divergence. So divergence of the velocity vector v is partial u by partial x, partial v by partial y plus partial w by partial z. Putting values of all these partial derivatives, partial v partial x is 2x plus partial v partial y x plus z, and partial w partial z negative 3x minus z. So 2x plus x will be 3x, that will be cancelled by this. Positive z will be cancelled by negative z. The answer is 0. So what we can conclude? The flow is incompressible. So if you get divergence of v non-zero, doesn't matter whether it is positive or negative, we say the flow is compressible. So at the moment we have divergence of velocity field as 0, so the flow is incompressible. So जब भी आपको कोई velocity field दिया जाए और आपसे ये डिमांड किया जाए कि इसकी compressibility चेक करें फ्लो की, तो आपने सिंपली डाइवर्जेंस कंप्यूट करना है उस वेलोसिटी फील्ड का, और डाइवर्जेंस कंप्यूट करने के लिए ऑफ कोर्स ये क्वांटिटी बनती है आप, और इसमें फिर आप ये पार्शियल डेरिवेटिव्स कंप्यूट करके तो कंप्यूटेशंस करेंगे. सो दिस इज हाउ you can distinguish between compressible and incompressible flows. The next thing we defined was the rotational versus irrotational flow. Rotational versus irrotational flows. तो इसके लिए हमने जो डिफाइन किया था, हम कर्ल कंप्यूट करते हैं वेलोसिटी फील्ड का, आई जे के, then component of del are partial v partial x, partial y partial y, partial v partial z, and here is u v w. If del cross v happens to be 0, we say the flow is irrotational, mean there is no rotation. And if this is non-zero, we declare that the flow is rotational because you are having some non-zero curl. So in fluid mechanics, this curl of V is also written like W, and we say this is vorticity vector. So if vorticity is non-zero, of course now we can write this as omega vorticity. If vorticity is 0, flow is irrotational, there is no rotation. If vorticity is non-zero, we say flow is rotational. So इसके रिगार्डिंग भी एक प्रॉब्लम हम सॉल्व कर लेते हैं. यही वाला हम u ले लेते हैं. v वेलोसिटी वेक्टर जो है x square plus y square plus z square, and then the second component xy plus yz plus z square, the third component minus 3xz minus z square by 2. इससे पहले हमने डिसाइड किया था कि फ्लो कंप्रेसिबल है या इनकम्प्रेसिबल है. फॉर कंप्रेसिबिलिटी यू कंप्यूट डाइवर्जेंस ऑफ द वेलोसिटी फील्ड, and to check the rotationality you compute the curl of the velocity vector. Now I'm going to compute curl of v, also known as vorticity omega. यहाँ वैल्यूज पुट कर दें. सो पार्शियल v पार्शियल x, यहाँ पे हम लिखेंगे u कंपोनेंट, यहाँ पे v और यहाँ पे w लिखेंगे, और आप इसकी कंप्यूटेशंस परफॉर्म करते हैं. I will directly write the result and you will be opening this determinant. So u is x square plus y square plus z square, v component xy plus yz plus z square minus 3xz minus z square by 2 plus 4. G, when you will expand this determinant, you would be getting something like this: minus y minus 2z with the unit vector I plus 5z with the unit vector j plus x minus y x or z, you may verify. Okay, but of course this is non-zero. So curl of the velocity field is non-zero. We can say that the flow is rotational. तो आपने अभी दो चीजें सीखी हैं. If you are given a velocity field and you have to decide whether the flow is compressible or incompressible, so you compute divergence. If divergence is 0, the flow is incompressible. If the divergence is non-zero, that would be compressible. And similarly, when you calculate curl of the velocity field, you can decide about the rotationality. तो ये दो चीज़ें हमने लास्ट टाइम डिफाइन की थी. आज जो है हमने इसकी कुछ प्रैक्टिकल या न्यूमेरिकल्स जो हैं वो देख लिए हैं. आपको इस तरह के क्वेश्चंस सॉल्व करने में अब कोई दिक्कत नहीं होनी चाहिए, बिकॉज आपको अगर वेलोसिटी फील्ड दिया है, यू आर एबल टू कंप्यूट द डाइवर्जेंस एंड ऑफ कोर्स द कर्ल, और इन दो की बेस पे, कैलकुलेशंस की बेस पे आप डिसाइड कर सकते हैं. ओके, नेक्स्ट थिंग आई वुड लाइक टू डिस्कस, जो थ्योरेटिकली आप पढ़ चुके हैं, स्ट्रीमलाइंस का जो कंसेप्ट था. सो फॉर 2D फ्लोज मोस्टली दिस कंसेप्ट इज वैलिड इन 2D फ्लोज. ओके, so if you are given some velocity field like u plus V plus W. For 2D cases, we would be having like UI plus Vj. Of course, you could write like this. All these are compatible notations, or you can write like this. So what is equation of streamlines? Derivation आप already कर चुके हैं. Equation for streamlines is, because streamline is defined like the lines that are everywhere tangent to the velocity vector. तो आप velocity vector की डायरेक्शन में एक टेंजेंट स्केच करें और फिर उस पर क्रॉस प्रोडक्ट लगाएं, जीरो के इक्वल करें, चूँकि ये पैरेलल बनते हैं. Streamlines are parallel to tangent to the velocity vector, so these vector would be parallel. और क्रॉस प्रोडक्ट को जीरो करके you have arrived at this situation, dx by u equals to dy by v. So based on u and v, you solve this equation and then you arrive at the equation of streamlines. अगर तो वो कोई ऐसी शेप जनरेट हो जाती है, ऐसी कर्व जनरेट हो जाती है कि जिससे आप फेमिलियर हैं और आप इजीली स्केच कर सकते हैं, तो उसमें से, उस फैमिली में से कुछ कर्व्स को आप स्केच भी कर सकते हैं. तो यहाँ पे मैं एक प्रॉब्लम करना चाहूँगा रिगार्डिंग स्ट्रीमलाइंस. वी आर गिवन सम वेलोसिटी फील्ड axi minus ayj and a is some constant 0.3 S inverse. And we have to find equation of streamlines. So dx by u equals to dy by v. इसको solve कीजिए, it's very easy. So dx over ax equals to dy over minus ay. This a will be cancelled by this. So dx over x equals to minus dy by y. Integrate कीजिए, log of x is equals to minus log of y. तो अगर ये दोनों log की form में, it's better to write constant in the form of log so that we are able to cancel this constant log on both sides. So log of x plus natural log of y, log of c. By the rules of logarithms, you could write like this, and xy equals to c. So can you recognize this family? This is family of rectangular hyperbolas. You might have read in your calculus course, rectangular hyperbolas. So based on the value of c, you have some sketch. So if you sketch in this first and third quadrant, this is one member of the family. This will be the second member, third member. Of course, you could have in the second and fourth quadrant as well. If you are further asked that sketch the member that passes through the point 2, 8. So look at this figure. यहाँ पे हमने बहुत सारे मेंबर स्केच किए हैं. अब एक पर्टिकुलर मेंबर को हमने स्केच करना है जो कि इस पॉइंट से पास कर रहा है. So this is the value of x, this is value of y. Based on this x and y, we can calculate this c. So xy equals to c, 2 times 8 equals to c. So c is 16. So now we have a particular solution, xy equals to 16. So the product of x and y is 16. So now we can sketch this is x, this is y. So when x is 1, y starts from 16. Okay, so the point 1, 16. When x is 2, we have 2, 8, because 2 8s are 16. Similarly, when x is 4, y would also be 4. So these are the points. Now you can sketch this member. So this is the streamline that passes through this point 2, 8. So on this curve, the product of x and y is 16. Of course, when you have this x as 8, y would be 1. You have this point. When this is 16, this x would be, sorry, for 8, the x would be 2. For 16, x would be 1. And this x-axis would be an asymptote to this streamline. Of course, when x is negative, y is negative, again you can have the product as 16. But we need to find that passes through 2 and 8. So x भी पॉजिटिव है, y भी पॉजिटिव है. ऑफ कोर्स आप सोच रहे होंगे कि पहले हमने जब स्केच किया था तो हाइपरबोला का जो सेकंड कर्व है वो यहाँ पे था, लेकिन इस वक्त हम इसमें इंटरेस्टेड से, चूंकि 2, 8 पॉइंट सिर्फ फर्स्ट क्वाड्रेंट में ही आपको मिल सकता है. एक छोटा सा प्रॉब्लम और कर लेते हैं. So you are given a velocity field uv, where u is 6y and v is 3. Same question, find the family of streamlines. Find the family of streamlines and sketch some members of the family. So it's very simple. We know dx by u equals to dy by v. Solving this relation, we are able to find equation of streamline. So dx by 6y dy by 3. So separation of variable would give you 3 dx is equals to 6y dy. So you could cancel this 6 and 3. So we have dx is equals to 2y dy. Integration would lead to x equals to y square plus some constant. You could add this constant maybe on this side. It is up to you. So y square equals to x plus c. So this is a family of parabolas. Of course, now you can sketch it by taking c equals to 0, c equals to 1, and c equals to 2. So for c equals to 0, we have y square equals to x. So this is y square equals to x. Then we have one member like this, and so forth. This is the family of streamlines. So I leave one problem for you. Find equation of streamline and sketch some members. So velocity field is given as u is minus 2y and v is 2x. तो इसको सॉल्व कीजिए और प्लॉट कीजिए, देखिए आपको स्ट्रीम लाइन्स कैसे मिलती हैं. So that is sufficient for this lecture. So we'll be meeting in the next class and doing some more numericals.